Okay, today we're going to learn about solving quadratic inequalities. We're going to do this graphically as well as learn how to graph quadratic inequalities. First, we're going to take a look using a transformation. So we have y is greater than or equal to x squared minus 3. If you recall, this simply means that we're taking the parent function x squared and we're moving it down 3 spaces on the coordinate plane, giving us a point at x equals 0, y negative 3. That's our vertex. We pick another point like x equals 2, plug it into the equation. 2 squared is 4, minus 3 is 1, giving us a second point to graph on our parabola, and then we use a symmetric point on the other side. Using those 2 points, we create the graph. From there, we have to graph where y is greater than. So, I'm assuming that's going to be the point above the graph since it's greater than. But just to be sure, I'm going to go ahead and check out a point, and I'm going to check out the point 0, 1. If that point works, then all the points inside the parabola will work. So I use the value 0, 1, and plug 1 in for y, 0 in for x, and then test to see if the statement is true. Is 1 greater than negative 3? It is true. Therefore, all the points inside the parabola will be answers that will work in this equation. So if I picked 0, 0, 0 would be greater than or equal to negative 3. 1, 1. 1 would be greater than or equal to 4 minus 3, which is 1. So the statement would hold true for every single point inside the parabola. In our next inequality, we're going to actually solve this inequality. Notice there's no y. We're going to be solving x squared plus 2x is greater than positive 3. We bring the 3 over to the left-hand side, giving us the inequality x squared plus 2x minus 3 is greater than 0. We then factor the inequality into x plus 3, x minus 1 is greater than 0, giving us the solutions that x is equal to negative 3 and x is equal to 1. We then plot these 2 points on the graph, negative 3, positive 1, our 2 zeros, and then what we're going to do now is we're going to find the axis of symmetry. We do this by adding our 2 points together, negative 3 plus 1 divided by 2, which gives us negative 2 over 2, which gives us negative 1. So our vertex will be located on the axis of symmetry at x equals negative 1. Okay, so we have x equals negative 1, and we're going to be looking for our y. We find our y value by plugging it into the equation, into the inequality, and we get that y is equal to negative 4. We then plot that point on our graph, negative 1, negative 4. This is our vertex. And then notice when I drew the graph has a dash line because we have a greater than symbol, not a greater than or equal to. Dash is for just greater than, solid is for greater than or equal to. Now if you notice, there's no y. We are actually solving for when this inequality is greater than 0. The greater than 0 line, or the 0 line, relies on the x-axis. So we're looking for those values that are greater than the 0. On the right, this would be the section that's greater than 0, and on the left, this would be the section that's greater than 0. We represent them by talking about their x values, because these are the y values that are greater than 0, and we say for those values greater than x greater than 1, on those value of x less than negative 3. This gives us our solutions from negative infinity to negative 3 in union with 1 to infinity. Notice I used a set of parentheses, not brackets. Brackets would indicate only if it was greater than or equal to, but it is greater than, simply greater than, so we use parentheses. Next, we're going to do an inequality that will require us using standard form. Y is less than 2x squared minus 8x plus 10. We use our x equals b, negative b divided by 2a. So we have the negative of negative 8, which is 8, divided by 2 times 2, which gives us 8 divided by 4, which is 2. 2 is our x value of our vertex. We then plug the 2 back into the expression above. And then solving it, we get that our y value of our vertex is 2. So our vertex is 2, 2. We then are going to graph this on our coordinate plane, 2, 2. And then using our slope of 2, we go up 2 and over 1 to get our point. And then we get our symmetric point. And then since it is a less than sign, not an equal to sign, we use a dash line to get our parabola. Notice we're looking for the y values that are less than this graph. And so it makes sense, therefore, that it'll be the values that are under the graph. So what we're going to do from here is we're going to, again, test a point. And I'm going to test the point 0, 0. I like 0, 0 because it's easy. So we go ahead and put that into our equation. 0 is less than 2 times 0 squared plus 8 times 0 plus 10. And we get 0 is less than 10, which is a true statement. So our graph is correct. So that's 3 examples of graphing inequalities, and in one of them we solve the inequalities. If you have any questions, please feel free to ask in class tomorrow. Get a handout because this is not, the practice for this is not on Khan Academy. See you tomorrow.